This video is now covering the back of the worksheet titled Notes, Equations of Lines. I think that's what it is. Take a look. Yep, Notes, Equations of Lines. You should have already watched the videos. I think there's 2 videos on the front side of this page dealing with parallel lines and the properties of parallel lines. The back of this page deals with the properties of perpendicular lines. Some of these questions might be repetitive because you may have already watched the videos to fill out the flipbook. We may have discussed some of these topics already in class, but let's go through this again, hopefully help you to get a better long-term memory of these properties. So, one of the things we have learned is perpendicular lines have slopes that are opposite reciprocals. Opposite reciprocals. Let's quickly remember that when we're talking about perpendicular lines, if I have a line segment that exists and I am looking to create a line that is perpendicular to that line, I'm looking for any line or line segment that where it intersects this existing red line, it intersects at a right angle, means it is perpendicular to that line. Now that blue line can be anywhere. It could be here, it could slide down the line this direction, slide up the line. As long as it meets the red line at a 90-degree angle. And that means that every one of these angles are 90 degrees. This one, this one, this one. All 4 angles created are 90 degrees. That means these 2 lines or line segments are perpendicular. So perpendicular lines have slopes that are opposite reciprocals. So question number 16, what is the opposite reciprocal of 2? Now remember, 2, if we convert that to a fraction, is just 2 over 1. And I like to convert it to a fraction first. And now let's convert that to opposite reciprocals. So if a line or line segment has a slope of 2, then any line that has a slope that is the opposite reciprocal of 2 must be perpendicular to that line. And the way we do opposite reciprocal, reciprocal means, let's do this in color so we see this. Reciprocal means flip the fraction over. So instead of 2 over 1, a line that is perpendicular to a line with a slope 1 will have a slope of 1/2. That's reciprocal. And opposite means, I'll underline there, opposite means flip the sign. This is a positive 2, therefore the slope of a perpendicular line will be negative. So negative 1/2 is the opposite reciprocal. Alright, let's follow that along. In fact, right now you should pause the video, do B and C on your own, and then play the video and take a look at the answers. Okay, let's do B. If the slope of the current line is negative 1/3, the opposite reciprocal will be, first we flip the fraction over, so instead of 1 over 3, it's 3 over 1. And because the sign of the existing line is negative, the sign of the perpendicular line will be positive. So the slope of a perpendicular line to a line that has a negative 1/3 slope will be a line with a slope of 3 over 1. And I can write the sign as positive, but you don't have to write plus. If we don't have a sign, that means we're assuming it is a positive slope. But I'll write that anyway. Let's go ahead and do the next one. Letter C, if the current line has a slope of 5 over 2, then the perpendicular line will have an opposite reciprocal slope. Let's flip the fraction around. That becomes 2 over 5. And because this slope, the existing slope, is positive, the new slope of the perpendicular line will be negative. All right, let's go through 17, 18, and 19. Here is an equation, y equals 2x plus 3. That's going to be the graph of a line. Question is, what is the slope? Well, we know the slope is m, right? Y equals mx plus b. M is the slope. So the current slope is 2, and I'm going to write that as 2 over 1. What is the slope of the perpendicular line? It's going to be the reciprocal, and then from positive to negative. Number 18. Y equals negative 1/3 of x plus 2. What is the slope? The slope on this line is negative 1/3. There's our slope. So the slope of a perpendicular line is reciprocal, 3/1, and then opposite means a positive. Now you could have also written this as just 3. 3/1 is the same as 3, and a positive, the plus sign, does not need to be written. We assume it's positive when there's no sign. Oh, you can take a look now, class, if you're noticing these are actually matching up with A, B, and C. So number 19, the function of x is equal to, or f of x is equal to 5/2 x minus 4. What's the slope? It's the coefficient on the x variable. So the slope of this line is 5/2. And that means the slope of a perpendicular line is reciprocal 2/5. And this is positive. We flip the sign, and so the sign is going to be negative. All right, let's move on to question number 20 and apply what we're learning about the slope of perpendicular lines. Let's take a look at question number 20. Graph the equation y equals 2x plus 3. So let's see, by graphing, class, all they're saying is plug in a whole bunch of x values, find out what the y values are, and then plot those on a graph. And you'll end up with a line, because this is, if you remember, our slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. Okay, so graph the equation y equals 2x plus 3. What's the y-intercept? Well, here it is right here, positive 3. That means let's go ahead and plot that right now. 1, 2, 3. That is positive 3 on the y-axis. That's where the line's going to cross the y-axis at the y-intercept. And the slope is the m value. So the slope here is 2. Let's go ahead and change color there so we see the slope is 2. And we could also write that as 2/1. Since 2/1 is a fractional equivalent or equal to the number 2. And let's underline this so we see that's the y-intercept. Okay, 21. Graph a perpendicular line which passes through 2, negative 1. Oh, hold on. We have to finish this. It says graph the equation. Well, we know this is the y-intercept. The slope is 2/1. That means we're going to go positive 2. And I'll write this. Positive 2 will be our rise, and positive 1 will be our run. So we're going to go positive 2 is the rise, positive 1 is the run. Positive 2 is the rise, positive 1 is the run. And now we can actually go opposite of that. Instead of going positive 2, positive 1, we can flip both signs, negative 2, negative 1. Remember, negative divided by a negative is the same as a positive. Let's put one more point here. There are our points. Let's go ahead and graph that line. I'm going to make that line a little bit thinner so you can maybe see the points. Here we go. And actually, that was pretty good. Let's put some arrows on it. And now we've completed question number 20. Graph the equation. Question number 21. Graph a perpendicular line which passes through 2, negative 1. All right, no problem. Let's go ahead and graph this point or plot this point. Positive 2, this is x, remember, there's our x value, there's our y value. Positive 2 on the x-axis, negative 1 on the y-axis. So there is our point. And they want us to draw a line that is perpendicular to the green line and passes through this. It sounds complicated, class, but it's not that bad. Let's follow the instructions. First of all, we should determine what's our new slope. If our slope of our existing line is 2/1, a perpendicular line will be opposite reciprocal. So instead of 2/1, reciprocal is 1/2, and that's positive on the original line. The perpendicular line will be negative. So our new slope is going to be negative 1/2. Okay, well, let's write that out in terms of rise over run. You can put this negative sign on top or bottom. It's one or the other, but class, it's not both. If there's negative on top and bottom, that's actually positive 1/2, because a negative divided by a negative is a positive. So let's put the negative on top. So we can just write it as this, negative 1/2. over 2. That means it's going to be a -2 rise, sorry, -1 rise, and a +2 run. So let's do a rise of -1 and a run of +2. A rise of -1 or down 1, a run of +2. Okay, we can do the opposite over here. Let's flip the signs, and now we'll do a rise of +1 and a run of -2. We just go ahead and make the opposites. And here's our next point, and here's our next point. If you ever plot a point wrong, it's easy to figure it out, because when you go to draw a line through them with your straight edge, you're going to find they don't line up. Let's go ahead and make a purple line through those points. Let's get it as exact as we can. Again, please use a straight edge for that so you get precision. And let's put some arrows on the end. There is our line. And we needed to do that because when it says what is the y-intercept of the new line, well, where does the new line cross the y-axis? Exactly at y = 0. So my answer is the y-intercept is 0. And I put a line through my zeros so you can tell it's a number and not a letter. What is the equation of the new line? It's not a problem. We know our slope. We know our y-intercept. Let's go ahead and write the equation. The equation is y equals, our slope is -1/2 x. Our y-intercept is 0. I can put +0. But now think about it, class. 0 doesn't do anything, so I could also just write it as y equals -1/2 of x. Adding 0 doesn't change the values of y at all. So you can put +0, or you don't have to put that at all if the y-intercept is 0. Okay, compare and contrast the two lines. I'm going to leave that for you. Actually, no, let's talk about that for a moment. Compare and contrast. Compare. What's the same? What's the same between these two lines? And contrast. What's different between these two lines? Okay, let's look at what's the same. Well, I only see one thing that's the same between these two lines, and that's this point right here. And I don't even know what the coordinates of that point are, actually, because it doesn't look like it falls exactly on the graph. So when you write compare and contrast, what I would say is these lines are only the same at the point of intersection. There's the sameness. And they're different because they have a different slope and a different y-intercept. So there's an idea of how you would write this. These two lines are the same only because they intersect at one point, or they're only the same at the point of intersection, and they're different because they have a different slope and a different y-intercept. You could also put in here, I also know that these two lines meet at a 90-degree angle, or you can say these two lines are perpendicular.